If I want to find the exact value of an expression without using a calculator, that means my values are going to be on the unit circle. So here the arc cosine of 1/2. Really what I'm asking is what angle between 0 and pi inclusive has a cosine value of 1/2. The reason I know between 0 and pi is because our cosine is defined in the first and second quadrant. So I've got to limit my answers to the first and second quadrant. And the value I'm looking for is 1/2. So let's go to my unit circle. And I'm looking at either the first or the second quadrant since I'm looking at arc cosine. And we know cosine are the x values. So where do I have an x value of positive 1/2? Got an x value of positive 1/2. Here it's 60 degrees or pi over 3. So the arc cosine of 1/2 is 60 degrees or pi over 3. Tangent inverse is square root of 3. Once again, I'm going to ask what angle between negative pi over negative pi over 2 and pi over 2 has a tangent value of square root of 3. So tangent inverse is saying I'm looking at the first and the fourth quadrant. Those are the only two quadrants that tangent inverse is defined in. So if I look at tangent inverse and I go to the first quadrant, I see a square root of 3, which is what I was looking for. And that is also going to be 60 degrees or pi over 3. The final one, the arc sine of negative square root of 2 over 2. So this is asking me what angle between negative pi over 2 and pi over 2 has a sine of negative square root of 2 over 2. And if we look at that, we're going to see that it's negative 45 degrees, or a negative pi over 4. You might look at your unit circle and say it's 315 degrees. But remember how arc sine is only defined from negative 90 to positive 90. So I've got to write my answer in terms of what the function is defined in. The last couple examples here are going to involve using the calculator. The arc sine of negative 0.645, using our calculator, we want to round to the nearest hundredth. Arc sine is the exact same thing as the sine inverse. And if I'm in degree mode, that gives me a negative 40.166 degrees. And if I'm radians, it's negative 0.701 radians. So arc sine in terms of using our calculator is the same thing as sine inverse. Arc tangent of negative 34, we're going to find the tangent inverse of negative 34. And if I'm looking for my answer in terms of degrees, this would be a negative 88.315 degrees. And if I'm looking at it in terms of radians, it's negative 1.541 radians. So once again, we're looking at specifically, are we in degrees or radians? And since this is something I've got to use my calculator for, I don't have arc tangent or arc sine. I've got to input sine inverse or cosine inverse. The last thing is using inverse trig to write theta as a function of x. And theta is going to be right here and right there in those two problems. So looking at the first problem, I want to write this using either sine, cosine, or tangent based off of what I've got. And since I'm using this theta, this 12 here is the adjacent, and this x is equal to the hypotenuse. Probably should draw on those right angles so you can see that that's the hypotenuse. So adjacent and hypotenuse. Since those are the two pieces I'm given, I'm looking at the cosine of theta. The cosine of theta is the adjacent over the hypotenuse. So the cosine of theta is 12 over x. I can then get rid of the cosine by taking the cosine inverse to both sides. So So cosine inverse and cosine simplify. So then theta is really the cosine inverse of 12 over x. Or we could write it as the arc cosine of 12 over x. The other example we've got, based off of theta, we've got the opposite side and we've got the hypotenuse. Opposite and hypotenuse is the sine. So the sine of theta is opposite over hypotenuse. The sine of theta is going to be x over 4, or x minus 4, over 49. We'll take the sine inverse to both sides. Sine and sine inverse cancel out. So I'm left with theta being the sine inverse of x minus 4 over 49. Or we can say it's the arc sine of x minus 4 over 49.